Right, so as I said earlier, the distributive law is really, really important for being able to both expand and factorise. And that's a skill that's going to come up more and more and more as you guys venture into the new senior syllabus. So the distributive law, I've given us the baseline here. So we've got a coefficient at the front of some brackets. And that can be expressed as, what's the operation that's applying to both of those? Multiplication. So we can express that as A times B, which you write as AB plus AC. Okay. It doesn't matter if that's BA or CA. It doesn't matter about the order. Cool? Doesn't matter because we're doing multiplication. Vice versa, if I had this as an expression, so if I had an expression as 2B plus 2C, I could write that as 2B plus C. Happy with that? That's called factorising. I've taken the common factor. What's the common factor? 2. I've taken the common factor out the front and made that look a lot simpler. If I had a division applying, and when we're talking about our algebraic fractions, so if this was over 12, for example, over 12, why would that be powerful? What would that allow me to do? Couldn't I do anything with that? Can I simplify that any further without being able to factorise or not? That's as far as it gets. But when I factorise that 2, what can I now do? Divide the bottom by 2. So I can divide the top and the bottom by 2, and I'd be left with that over 6, which is the simplest form. Happy with that? So it's, yep.
Are you putting this on your classroom?
Yeah, I'll put the video up, yep. Okay. It's really important that we can both factorise and expand, and we'll show you why that comes up later on. But it's really important that you understand that's the distributive law. So when we talk about the distributive law, it means you can expand a term into both, or you can factorise a key term out. Cool? If this was 2 and 3, could I do anything with that? Why not?
Because then you couldn't have the same. You'd be able to have the same units at the front.
Yeah, so I can't divide both of these by 2, and I can't divide both of those by 3, can I? So it's not a common factor. How do you tell whether you've got a common... What about 2 and, let's say, 4? Could I do something with that? Why could I do something with that? 2 is a factor of both 2 and 4, so that would become 2C there. Cool? I'll rub that out so we don't get too confused. Do you want to do the example or go on to the tricky one first? We'll go to the example first, then we'll come back to the tricky one. Okay, so our example here, we've got 3 outside of x plus 6. Now, if ever I can't remember the distributive law, I like to just shove a number in. So put a number in that for that x in your head. I want you to pick a number now in your head and we'll see if it works. The smaller the number, the easier it'll be. Cool? How do we express that? Mitch?
It would be 3 times x and 3 times 6.
Yep, so can I write 3 times 6 in quickly? What's that? 18? Okay, very good. Dylan, what was your number? 1? 3 times, what's 1 plus 6? What's 1 plus 6? We know the brackets, we do that first, correct? So 3 times 7 is?
21.
Okay, good. 3 times 1? Plus 18?
19.
3 times 1 is what?
Oh, 3.
Plus 18?
21.
Very good. So does the law work?
Yeah.
Very good.
We use that to keep it more manageable.
Yeah. So that's just being able to go between being able to factorise and expand depending on what we need. These are tools. We use them as we need them.